Okay, in this video we're going to look at something called the cross product. So again, I have to preface this video. This is going to be a tutorial on how to use the cross product, how to calculate the cross product. Does not replace the work you're going to do in class, where you're going to prove it and you're going to see why this works, and you're going to be in your groups working with it with your teacher and your fellow classmates. So again, what is the cross product? So this is what it looks like. So you might think this means multiplication, but it doesn't, because we know multiplication with vectors is the dot product, and you have the dot. So when they use the x there, they are referring to the cross product. Now, I don't want you to get too hung up in what we got here. This is how you're going to calculate it, and that's not going to look very useful right now. So let's draw a picture first to see exactly what this is going to do for us. So again, the cross product only happens in 3 space. So when you have 2 vectors, I'm going to draw 2 vectors here. So I've got vector A and I got vector B. So the cross product, when you do the cross product, the 2 vectors, that's going to give you a vector that is perpendicular to A and B. So again, this would be the cross product, A cross B. So it's going to give you a perpendicular vector to A and B. That's the purpose of the cross product. So that would be A cross B. The negative of that, B cross A, and go the other way. Again, perpendicular. And again, this is all in 3 space. So again, how are we going to calculate it? So you might be looking up here and looking what looks like a formula and saying, what is this A2, B3? So let's look at 2 vectors. So I got vector A and I got vector B. And again, these could have been like vector P and vector Q, right? So again, that doesn't really matter what the variables are. So this would be A1, A2, A3. So X component, Y component, Z component. This would be B1, B2, B3. X component, Y component, Z component. So you can, if you choose, you can go right that you now know which is which. You can go and you can sub them in right into this. Or you could do this. You could set up a table and basically do the same thing. I think the table is a little bit clearer, but that's going to be up to you. So in your table, right, A cross B, so A is first, that's really important. Set it up like this. You got your A table, your vector A table. So the first entry is A2, the second one is A3, the fourth one is A1, and oops, I think I did, nope, that's right. So we got vector A, so first one is A2, second one is A3, third one is A1, and the fourth one is A2. And then vector B, same thing, but with the B components, B2, B3, B1, and then B2. So then that same thing we had up there, it's going to happen here. But this is kind of a nice way to kind of do it. And again, in class, I would give you this table, and I would give you that other formula there, if you want to call it that. All right, so you're going to go like this. Here we go. First one, what we got to do is now we got to put in the numbers. So again, so that's how you set it up. So now I'm going to go over here, and I'm going to actually put in what the values are. So A2 was 3, A3 was 2, A1 was -1, and it starts again with A2. So B2 was -5, B3 was 6, B1 was 2, and then it starts again with -5. Okay, here we go. So I'm going to change to red here. So you kind of go on a cross here. You're going to go 3 times 6, which is 18, so you can actually start to fill it in. And then it's subtract 2 times -5. So be careful, because subtract, that's going to be -10, but subtract is going to give you +10. Comma. Now we're going to go cross again. we're going to go 2 times 2, which is 4. Go right there. Subtract -1 times 6 again. Subtract -6, which that's going to be plus. And then the third one, you can see what's happening here. That's going to be my x component of the vector. That's going to be my y component of the vector. So the last one is going to be -1 times -5. So that's going to be +5. And then subtract 3 times 2. So again, always watching that negative. Okay, that's easy to miss. Okay, 18 plus 10 is 28. 4 plus 6 is 10. And 5 take away 6 is -1. So this right here, this vector, is perpendicular to both A and B. So again, you can calculate the cross product using the table, using the method I just showed you, which is exactly the same as if I wanted to just plug them right in here. See, when you figure out which is A2, AB3, and all the other components, you can just sub them in right there. But this right here is exactly that. I just think using that table is a little clearer, but that's going to be up to you. So, is this vector perpendicular? Well, we have a perpendicular test. So, let's go back to A. If it truly is perpendicular, that means if I do the dot product with this result of the cross product, it should equal 0. And let's see if it does. Yes, it does. So check. Now it's got to be perpendicular to both vectors, so it's also got to work for B. So let's check. So 2, -5, and 6. Dot product. So 2 times 28 is going to be 56. -5 times 10 is -50. 6 times -1 is -6. And yes, check. So again, if it is perpendicular, which it is, that's what the cross product will give you. Perpendicular vector to those 2 and 3 space. When you do the dot product, it should equal 0. So A cross B, we calculated, was the vector 28, 10, -1. So if I wanted B cross A, I could go back and I could set up the table. Now if I'm doing B cross A, when I set up my table, B would be first. But that's just going to be the perpendicular vector going in the opposite direction. So B cross A would just be that same vector, but the opposite, which means I can just multiply by -1. So again, just got to be careful. The cross product, really easy to make an arithmetic mistake.